Hello everyone, welcome to day 2. We're going to be going over logarithmic functions and their properties. So the log function is the inverse of the exponential function. So if you guys remember, the exponential function is y equals b to the power of x. And in order to find the inverse function, we switch x and y, right, which was done here. And now we solve for y, right? So to solve for y, I'm gonna get the log of both sides with base b, and I'm doing that so that I could get the y to cancel out, the b to cancel out here. And then log b and this b are gonna cancel, and you get y equals log bx. And this is just to show the arithmetic behind this relationship. And now graphically to demonstrate the log function, since it is the inverse of the exponential function, it's gonna be symmetrical about y equals x. Right, and now so this is your log function. This is what the graph looks like. And this is for b greater than 1. And we're doing greater than 1 because this function is differentiable when b is greater than 1. So then this, because this is the inverse, it's going to also apply here. And here are some cancellation properties that are showed in the book. So in order to say you have b to the power of x is equal to something and you want to cancel out that b, you could apply the log b, and this will cancel and you would be left with just the x. And another cancellation property is when you have b raised to log b with the same base, they cancel and you get x. This section also reminds us of the laws of logarithms. So if you have a log of two values x times y, you could expand them using addition. If you have log of two values divided, you expand by subtracting. And then if you have a log of a value raised to the power of something, you could bring that power out to the front. And the natural log is just a special logarithm with base e. And something that I forgot to mention in the last video is the exponential e to the power of x is one of the most used in calculus, so that's why they put so much importance in e in this section. And in the same way, the natural log is maybe the most commonly used in calculus, which is ln x. And another important thing to remember is ln e is always equal to 1, right? Because we have an invisible e here. E to the power of 1 is e. So this is also important to remember and helpful. And here are some of the cancellations for the natural log. So if you have an ln to the power of e to the x, these could cancel, you get x. And when you have e to the power of ln x, these cancel and you get x. And here's the change of base formula, which is useful for like if your calculator doesn't allow you to put a custom b and you only have a ln or a log button, you're able to separate it into this form. And now let's do some practice problems. So using the properties of logarithms, we know that when we're dividing two values, we could subtract. So this is going to look like this, x to the 5 minus ln, and this is x squared minus 36 to the power of 1/2. And then we could bring this to the front, right, which is one of the other properties. And that's it. And wait a minute, this one too. So 5 ln x minus 1/2 ln x squared minus 36. I was like, this is the answer. So And now let's solve these. For the first one, it's about a bit of mental math. So thinking about what value 3 to the power of what will give you 81. And we know 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, so then x equals 4. So then this is going to be 4. And then for this one here, this one's a bit different. It's a bit more work, so I'm going to write, so 25 to the power of x equals 5. And then I noticed that I could match the bases, and when we have the same base, the exponents are equal to each other. So I'm going to write this as 5 squared to the power of x equals 5. So this is 5 to the power of 2x equals 5. And so then this 2x is equal to this exponent. Since they have the same base, the exponents are the same. So 2x equals 1, x equals 1/2. There you go. All right, now let's condense this one. So for this one, we are going to be working backwards using the properties. So here I'm going to start with the values I have in front of the logs, because I know I could bring them back up here. So this is going to be log b x to the power of d minus log b y to the power of c plus log b 7. And now I notice these are subtracting, and going backwards, that would go into division. So log b x to the power of d over y to the power of c, right? These values divided. Then I bring this down. And now these are being added, so that means that moving backwards, it's multiplication. So it's going to be multiplying this and this. So this is log b 7 times xd over y to the power of c. And just in its simplest form, 7xd over y to the power of c. That's about it. Tomorrow we'll be going over derivatives of these functions. So we'll see you tomorrow.